Now this is chapter 7. Okay. We're going to continue on from where we left off. Chapter 6, we started talking about object-oriented. Now we're going to pick up from there. Okay. We talked about it a little more in depth. We talked about a reference, testing for equality. We're going to walk through an example of that. We're going to talk about passing by reference, method called chaining, which is not this program, the one after that. So it's chapter 8. Or is it?
No, it's this one.
Is this one? The fraction? Okay, yeah. Okay, so fraction does require that one. Okay. It's kind of cool, and if you don't pay attention during that part, you will not figure it out. I mean, unless you read the book. But for the most part, it's not very intuitive. It's really awesome the way it works. It's one of those things that make sure you pay attention when we get there. We're going to talk about overload, which will probably be Wednesday, by the way. We'll talk about overloading. We'll talk about constructors, then overloading constructors. Okay? So, let's start in here again. Okay. So, this code fragment. What does this code fragment do? What does car do? All right?
Creates a car.
Creates a car. What type of object is this?
It's a car.
Little c or big C?
Big C.
It's a object of type big C car. First of all, is that a good naming convention there?
Probably
I mean, it works, but I kind of get confused. So yeah, we're creating an object called car. What type of object is it? It's car with a capital C. Okay? Now line 2 says car, the object we just created, is equal to a new car, big C. Can those be put on the same line?
Yes.
Sure they can. We could have said big C car, small c car equals new big C car. Done it all in one line. We could have done that as well. Okay? Line 3, car.year is equal to 1998. The object car obviously has a data member called year. We gave it a value. Okay? If we're assigning it this way, year is probably public, unless we're doing it inside the same. Well, it's probably public. So, all right. So, line 1, it says space is allocated for memory for the car reference variable. It says the reference variable will hold the address of the object. So, on line 1, we basically say we need a new car. We're creating an object of car. It's going to be of type car. But we tell it we're going to be putting it over there. It's kind of like buying a house. Kendi was going to buy a house. I bought a house at 84 Total Tree Line Drive. There's my address. Okay? So my deed really tells me what I own, the address of it. Okay? So it says the car reference variable will hold the address of the object, but since it's not created yet, it's not really legitimate. It's not really there until we actually instantiate it. Okay? So space is allocated in memory, but we really haven't done anything with it yet. Okay? Then the car value, we're on line, line 2 we actually have it, we just haven't, it's there, we just haven't done anything with it yet, okay? Then line 3 we actually go to the year part of it, which we'll see a picture on the next page, but we'll go to the year part of it and assign it a value, and at the bottom it talks as public, since we were able to access it that way. Alright, so here we go, here's our code fragment, okay? Let's look at this, alright? So, the car, small c car, really doesn't have anything in it yet. We basically say we will be creating an object called car. Gets a spot in memory, but it really doesn't point to it yet. We don't have it yet. Okay? Alright, then we get to line 2, and it says, okay, car is equal to new car. It basically says, okay, the car is located in memory address 1062. So from now on, whenever we reference car, we're referencing 1062. But not just 1062, we can reference all the data members of that object. So line 3 says the year is 1998. Trying to understand what's happening?
All that information would be in 1062.
Correct. Right, starting at 1062. Think of like, okay, a starting location 1062. Then maybe if we have year, obviously the year can be next. This is an integer. Then maybe the next one would be the color. So we could have the year, and then the color, and then the make, and then the model, then the whatever, okay? So you could have all that stuff, one after another. It's at 1062.
Oh, it's on 1062.
Yes.
But it's not holding the same thing at the same time.
No, it holds all of it at all times.
It's being replaced, right?
Right, because the small car up there where it says number 4, that holds the address of where the car is really stored. Okay?
I have a question.
Yes.
How do you tell, like you're saying 1062 is the memory address, is there a way to tell what the specific memory address would be, like if I wanted to figure it out? Just for
Yes, we can show you an example of exactly how to do that. You can actually print out car You say print car, it'll show you the address of car.
Oh,
And it won't tell you 1998,
right.
but it would print out 1062.
Is 1062 like a default address?
No, that's just an example. That has nothing to do with it.
That's
It's
what I figured.
totally, you're going to get a hexadecimal value. But that's just for an example on the screen type of address. Okay. So all the different components of the car would be stored starting at location 1062. And depending on the size of our object, it could go on for a long period. Or it could just be one little item. Okay? Kind of got that, hopefully? All right. The assigning references. The results of an assignment, one reference variable to another, is that both point to the same object. Okay? Now, we already talked about primitive values, like an integer. If I say int num equals 5, then what's the value at num? 5. Then if I say int num2 equals num2 would then have a 5 in it as well, because it's equal to whatever's in there. Okay? But the reference variable is a little different. Back here, what is inside of car? Small c car. 1062. You agree with that? So if I was to say car 2 is equal to car, basically car and car 2 would both be pointing to 1062.
It's the same color.
Just like when I said an integer num is equal to 5 and num2 is equal to num. Actually, let me show you that example.
But there can't be two cars at 1062.
No, it would be the same car. Let me where's my hello world?
No.
What do they not have installed in this? I'm glad they rebuilt this machine 5 minutes before class. Okay, no, it is there. Okay, good. I was freaking out there. Hold on, I gotta fix all my preferences. Alright, that's under Java. And we want the font. And we want Lucidia console. Lucidia console, and for you blind people, we'll go with a 20. Good enough? Alright, good. Alright, actually, let's see if this thing compiles, because I don't know what they've installed and what they haven't installed. Okay, good. We have that. Okay, so I'm going to go in here, and I'm just going to change out a little bit of this stuff in here. Int num equals 5. Okay? Int num2 equals num. Everybody understand what's happening there? I'm going to get rid of some of this stuff here so I can use this. Okay, I'm going to print out num2. Okay? So I declared a variable called num that's going to be equal to 5. So whatever location in memory num is, now has a 5 in it. Okay with that? Then we declare a new variable called num2, so we grab another location in memory. So, okay. And what do we put in it? We put in it whatever's in num. So the 5 goes in there. What?
If you change num2 will change too?
Yes, actually, that's a very good example. Let's do this. No, it doesn't, but we'll see. Hold on. Hold on, I got an error. What's my error? Oh, sorry. I wanted print. My fault. Heck. What am I doing? Just print line. Okay. So we get 5 and 5. Hold on, let me fix this too. Properties, fonts, Lucidia console, we'll go with a 20. Alright, y'all agree we got 5? 2 5s right there on the screen?
Yep.
Actually, we'll go a little bigger, because this is a smaller area. 24. Alright, so we got 2 5s. Alright, now, I'm going to go here, and I'm going to change num equals 6. So what am I going to get? Is this line with num going to print out a 5 or a 6? Should print out a 6, but what will this print out? Let's see. We get 5, 5, 6, 5. Okay, the first 2 5s are from here. Then we change num to 6. So here we get a 6.
Still hold the value.
Right, num2 didn't change. Because what we said was,
You haven't looked at that.
up here, we said create a new variable called num2. And it says we want it to be equal to whatever's in num. We didn't say move it there. We just said, you know, we want a copy of it, basically. Okay?
So it's just following the previous lines.
Yes.
Order. Had
Now-
you put those 2 lines below that, then it would have been to 6.
If I done what?
You'd have taken those 2 lines and put them, say,
Oh, these two?
no.
No.
Integer.
Num 2 equals num.
These two?
I'm just wanting to see how you could make num2 equal to 6. Now,
Oh, I could do num2 equals num. Oops.
So you had to do that again?
Yeah,
Yes, I would have to do it
That's what
again.
I was asking, basically.
Because what happens, I took a copy of num and put it in there. Because remember, 6 is a constant. It was the number 6 the day I was born. It's the number 6 today. So what we did, we didn't get rid of number 6 and pull it out of the inventory. We basically put a copy of it in num. So yeah, we left 6. Okay? Now they're both 6.
So essentially it's working like your calculator memory, where you can calculate, so you can calculate the 2 numbers.
Right?
Okay.
Yeah. Same basic thing. Do I have a mouse or something? Yeah, I got a mouse. Let's try creating a mouse real quick. Now, Karen, this is going to work. I don't remember what's in that mouse class. All right. So what I did here was I said, I want a new variable called myMouse. What type of variable is it? What's a mouse? It's equal to a new mouse. Everybody okay with me there? When I run it, I get nothing. What we did, I didn't tell it to do anything yet. We created a new mouse. So we have a location memory now that really has nothing in it. Now I'm going to just print out mouse. Whoops. Oh, my mouse. Okay? So now I'm going to print out my mouse. So, remember what we said back on the slides here. I'm going to go back to that slide. Remember, the small c car doesn't hold the year of the car. It holds a location in memory where it's stored at. So that's where the 1062 comes from. So when I run this, there it is. Mouse is stored at memory location 19821F. Everybody see that? What?
It's a huge hexadecimal
Yeah.
position.
Well, dude, we have, what are these, 64-bit machines?
Yeah.
It's got to be a big number. So let's play around with this a little more. I'm going to create another mouse. So I'm going to create my mouse 2. Now I'm going to print out my mouse 2. So we should get 2 different addresses. You agree? Yeah, one's at 19821F, the other one's at ADDBF1. So what that is, that's the actual location in my computer's memory where these mice are being stored. We haven't done anything with them yet.
Right.
We just did it, okay? Now, what if, instead of doing this line here, what if I said mouse, my mouse, I can't type tonight, equals my mouse. So I said, what a new object called my mouse 2. What type is it? It's mouse. What is it equal to? Is it equal to a new mouse?
No.
No, it's equal to whatever mouse.
So now they're at the same position.
Right. So let's see what we get. Now they're at the same memory location. You see that? So what we did is we created 2 of them, and they're now pointing to the same location.
So does that mean they become, they're 1, or they're still 2? Could you change 1 and then...
No, if you change one, you change them both. It's kind of like saying, okay, some of you know where my office is downstairs. It's my office, it's Susan's office, and Caleb's office. So all 3 of us have the same office number. And if we change Ken's paint color, does Caleb's paint color get changed? Yes, because we're all pointing. Caleb is his own person, but his office is mine. Mine is his, and same. So that's exactly what we did here. We said we got mouse 1 and mouse 2. They both point to the same location. Could I have multiple ones? Sure. What was in that mouse anyway? Let's see. Let's find our mouse. Properties. That's not what I want. Hold on. Oh, it's shift. Is that right? No, it's Shift. Where's open with?
Were you trying to open it?
No, I want to be able to set the default. There's open, but where's open with?
Set to.
Yeah, but it should just give me the open with. Oh well. I mean, I can.
Not unless you're logged in with an administrative account.
What now? I mean, I can do that, but I shouldn't have to do that. Okay. I'm going to create a new variable up here, just so I'm going to create a public variable. We're going to call it an integer. What do you want it to be? Year. I don't know. It's good enough. Okay. So I'm just editing the mouse class to have a year in it. Main it public just so we can edit this and make it work. Okay. So if I was to go in here and say my mouse one or mouse dot. Actually, I'm going to make it one dot year equals 1962. And if I said, gotta change this to a 1 here, change this to a 1, that to a 1, that way we can keep them separate a little bit. Okay.
You didn't declare mouse 2.
Yeah, equal to my mouse 1.
What? Oh. There we go. Alright. So what should happen? So we got my mouse 1, which is a brand new mouse. So we go in memory, we make a location for my mouse 1, and say it points over to this location. Then my mouse 2 is a new mouse, but it happens, instead of being a new mouse, it's equal to the same location that my mouse 1 is pointing to. So they're the same. So when I change my mouse 1's year, what happens to my mouse 2?
It changes.
Because then they're both pointing to the same location. So my mouse 1 and 2 are at the top. They both point to the same location. So obviously if we change my mouse 1's year, my mouse 2 year changed as well. You see that? Yes, no, maybe, hopefully. Okay. So what if, after I print all that out, what if I go in here and I make a mouse 3? But this one's going to be equal to mouse 2. And I want to see the year for mouse 3. What's it going to print out?
1962.
Sure. So I'm saying creating me a new mouse called my mouse 3. What's it equal to?
Oh, no, it's going to print the address of.
It's going to print a year. So mouse 3 is equal to mouse 2. So whatever was in mouse 2, which was that address, is now going into mouse 3. So when I say print out mouse 3's year, what do I get? Let's see. 1962 as well. Because all the R's are pointing to that one location. We only created one new mouse in this whole program. It's right up here. Now what if I did this? Now we're saying mouse 3 is not equal to mouse 1 or 2. Mouse 3 is equal to a brand new mouse. So let's run it.
See what the location of 0.
Well, first of all, let's see where the mouse is stored. So I'm going to get rid of the year. Okay? Where are we storing this mouse at?
Just gives it a
Oh, it's in ADDBF1. That's where we left
Oh,
it.
it doesn't have a year. You didn't assign it a year.
Right.
So when I say .year, I want to print out the year.
That's a 0.
That's the default value. Remember we talked about default values in the last chapter? An integer gets a 0. So I didn't give it a year. Did I need to give it a year? I did not have to because it automatically got defined or initialized as a 0. Everybody okay with that? Kind of following along? I just figured we'd do our own little example there. All right. So you kind of understand how this is working. Okay. So the result of assigning one reference variable to another is that both point to the same location. Both of our mice point to the same, whatever, 1982, FF1, or whatever that was. Okay. With both pointing to the same location, if the object is updated by 1, they're both updated. Okay. This can be disconcerting. It is. Okay. Aren't you glad that was a good comment? No. So suppose you want to create 2 cars. Okay. All are the same except for the color. Okay. My plan is to create my first car, copy the first car into the second car, then update the color. Makes sense. Obviously, you like my car because it's a Chevy Volt. It's awesome. Here, that everyone thinks that they're never going to sell. I have 3,800 miles so far, 1.8 gallons of gas. I'm doing good. All right, so let's continue on. So we have a car called Stacy Car. What type of object is Stacy's car?
Car.
It's a car. Okay. We have another car called John Car. John is obviously the author of the book, by the way. Stacy's wife. Okay. So John Car, another object, subtype car as well. But this time, John Car is equal to brand new car. All right. Then we're saying John Car said it's make to Honda. Set make is something they wrote. It's not part of Java. It was just an example. Okay. So John's car is a Honda. John's car is a 2003, and John's car is silver. We okay with that? So we say Stacy car is equal to John car. Just like mouse 2 is equal to mouse 1. Did we create a brand new car? Is Stacy car a new car? Just point to John's car. It's basically saying we both drive the same car. So when she goes out at lunchtime and changes the color of the car to peach, what happened to John's car? Yeah. Divorce time. John now drives a peach car.
Change it to beach.
Exactly. So if I wanted to in my program up here, so we know that mouse 2 is equal to mouse 1. So prior to this, if I said my mouse 2 dot year equals 1948, this is one old mouse. So what's the year of mouse 2 now? Mouse 2 is 1948. How old is mouse 1 though?
62.
Okay. Mouse 1 is 62. But what if I want to see the output here of mouse 1? So mouse 1's year is now what? Remember, we set mouse 1's year up here to 1962. Then we set mouse 2 to 1948. So how old is mouse 1? Why is it 1948? Well, let's look. So we set mouse 1 to 1962. Okay? Then what is mouse 1? Well, mouse 1's a new mouse. Then we have mouse 2. What is mouse 2?
Mouse 2 is equal to mouse 1.
Mouse 2 is not a new object. Mouse 2 is pointing to wherever mouse 1's pointing. Just like John's car and Stacy car. So when I said my mouse 2's year is 1948, what happened to my mouse 1's year?
Changes to 1948.
Changed as well. Because they're not separate objects.
So whatever mouse is declared last or changed last,
Exactly.
that becomes.
Exactly. So now what if I did this though? What if I change this to mouse 3? I can't yet. Hold on. Let me move my mouse.
It changed because mouse 3 is separate.
Oops. There. So, how old is mouse 1?
62.
How old is mouse 2?
62.
How old is mouse 3? Correct. 62, 62, and 48. Okay? It's the same thing we did in an example on the slides, just different. Exactly the same, but totally different. Okay. So, you can see how this could, if you accidentally do it wrong, you got a problem. All right. So, the problem with the previous slide's code is that Stacy car equaled John car. Stacy didn't get a new car. Stacy wanted a new car, but she didn't. All she said, John said, hey, you know, I only work in the day, you work at night, so we can share the same car. That's what happened. You know that's what happened. Okay. That's just probably the other way around. But okay. So Stacy car equals John car, statement causes the reference objects to point to the same object. Thus, John's car becomes peach, which we saw. Okay? So what happened is when we had John car and we set all those values, Stacy's car really points to the same memory location as John's car. So when we changed Stacy's color to peach, John's car also changed, just like our mice, mices, or whatever. Okay? Or my office, exactly. All right. If you want to make a copy of it, then you should not assign one reference to another. Instead, instantiate a new object and then copy the data over. So, this is how it should have been done. John car is equal to new car. Stacy's car is equal to a new car. And then we can go copy each one over. That's like Caleb saying, all right, I want a new office, and I want its color to be the same color as Ken's office. I want all the stuff that's in Ken's basically duplicated over. Now what happens when Stacy changes the color of her car?
That'll change Bill with John's law.
Right, because Stacy is a copy of John's. Okay? Didn't you ever do something like that? You say, I want the exact same. I went out to dinner the other day. I ordered something. My wife said, I want the exact same thing. So, did we eat the same plate? No. What they did is they created a new meal for her, but then her meal was just a duplicate of mine. Okay? All right. So, next slide, we make a copy of the John car reference verb by calling a make copy method. Make copy is not built into Java. You got to write it yourself. So many people think, oh, I tried make copy, but it didn't work. Well, did you write it? No. Well, you need to write it. Okay? So here's how it works. Okay. I know people listening to this can't hear this, but okay. In my left hand, I have a remote control. And, well, let me think. Okay. I want to put this remote control from my left hand to my right hand, yet I can't hold it in two hands at one time. So how can I do that?
Put it down.
I can put it down, so I can put the remote control down, pick it up with the other hand. Okay? Everybody see how I do that? Well, here it's kind of the same thing. You have to create a temporary storage location for it. So if I'm going to copy the car, I need to make kind of like a sample place and then copy the data over. Okay? How does make copy work? Well, instantiates a local variable named car, so it makes a new temporary variable inside there called car. It's going to hold it. Then it copies the values into it, then it returns it, which we'll see. Okay, let's look at this. All right, here's our main method. Again, this is not the make copy method yet. Okay? So we have the new John car and we have Stacy car. What's Stacy car equal to right here? Nothing. We will be buying Stacy a car. That's all we did. Haven't given her one yet. Then we said John's make, John's year, and John's color. Then Stacy's car is equal to John's car.make copy. In other words, we want to make a copy of John's car and return it. Okay?
So
And
there she is getting a car?
she's getting a car. We can see exactly how that works. Okay?
Honda, but each in color.
Right. Well, actually, it's going to be a silver 2003 Honda on line 1
That line.
at this line.
By the
The
next
next
line.
line.
The next line is going to change it to peach. All right. It's kind of like saying we ordered the same, I ordered a hamburger with pickles, and you say, I want the same thing as Ken, and then you get the hamburger with pickles, then you remove the pickles. Actually, it was kind of funny because my youngest son, who's now like 21, 22, something like that, wow. He's the only person I've ever seen do this. Yeah, anyone ever go to a restaurant and like tell him I don't want like no mustard or no pickles or something like that? A lot of people do that. He never does. He orders it the way it comes,
Takes it off.
and he takes it off. I'm like, dude, why? He goes, they won't screw it up that way.
My wife does the same thing.
It's when you make special orders, they screw it up all the time.
She does the same.
Yeah, but my son always ordered it as it comes, and he takes it off. I'm like, it's actually smart. I went to Chuck House, which is Del Rancho over here the other day. I don't know if you ever ate at Chuck House. Amazing.
Del Ranch?
Well, it used to be called Del Rancho.
Oh, okay.
Now it's Chuck House over on Douglas.
Okay.
Order a steak sandwich with extra onions, because if you ask for onions, you get onions. If you ask for extra onions, you just get whatever. I said extra, man.
Smothered.
They were like falling out of the bun. It was awesome. Oh, so yummy. Hungry now. Okay, but
Why are all the food examples at this time of night?
I don't know. Maybe it's dinner time. I don't know.
You better leave early and get something to eat.
All right, let's continue on. All right. So let's see what the make copy method looks like. So here's our make copy method. So remember, we called this from John's car. We said Stacy's car is equal to John's car, make a copy of it. See that? So really we're making a copy of the John car. And whatever that returns is going to go into Stacy. All right? So, make copy. Receives no arguments. Create a brand new temporary car right here. So we went out to memory, made a brand new car. We called it car. It's brand new. It's equal to brand new car. It's just got nothing in it yet. Then we said, I lost my mouse. That car's make is equal to this make. What is this make? Well, since we called it from the John car, is equal to the make of John's car. And we said car.year is equal to this year. Since we called it from the John car, this year is John's year. So this new car's year is equal to John's year. We're saying this color, again we called it from John, so whatever John's color was, is now equal to the new car's color. So the new car is the same make, year, and color. Then we return car. So the brand new car we built, we said, there you go, Stacy, it's yours. But really, since, remember when we printed out mouse a little bit ago? We printed out mouse all by itself. What did we print out? The memory address? Remember that 1982 something or other we were printing out? Well, so when we return car, were we really returning the car? No, we're really saying, oh, Stacy, your car's over here. We built that car and left it in the driveway for her, and we said, Stacy, your car's right there. Go get it. Okay? Everybody kind of see how that works? All right. So return car really just takes the address of that car, and right there at number 1, takes that address of the car, the brand new car that was just made, and assigns the address to Stacy. So Stacy now points to that new location. Okay?
So when you say return car, it's Stacy's car?
Right. Well, it's going to be Stacy's car.
Okay.
It's kind of like saying you go into the car dealer and say, hey, Ken already owns a car, and you say, I want the exact kind of car as Ken.
Just like that. Okay.
So what happens is GM's going to say, all right, we need a new car, so they're going to build a car. Then when they're done, they're going to ship it to Huderberg over here or somewhere.
Mm-hmm.
Then they're going to walk up, and is it, what's Jones. Devin. So they're going to go, Devin, your car is located in spot number 2. So they built the brand new car. And then once they're all done building it, then you make your modifications to it, and then they just tell you where your car is. Okay?
So in this example,
Yes.
if we didn't have the car equal new car,
Right.
if that wasn't there, then it would return a reference to John's car, right? Or would it?
It would act, if you did, you would have to say return this.
Well,
Okay, so if we didn't have this top line right here,
yeah.
Yeah.
well, first of all, this part on the left wouldn't work
Okay.
because we can't assign a make because there isn't one.
Okay.
It wouldn't be
We could have done this differently. We could have, we really could have just said Stacy dot color, create a brand new car and said Stacy color is equal to this, but just wouldn't be as handy. Okay. All right. All right. Now, everybody kind of with me there? Pretty much got the idea of how it works? Okay. All right. Where we're going, we're not going to finish this whole chapter tonight. Darn it. Or Wednesday, at the rate that's going. Okay. It's 7:55 and 49 seconds. There's a clock over there. Just turned
Junk
off.
house closes in 4 minutes.
No, they closed at 9.
Oh, okay.
I ate there last night.
Okay.
No. I'm doing my juice fast again this week, so I
I
can't.
tried.
Yes. But it was so yummy. They make the best fried okra in the world, by the
What
way.
is this at?
Right on Midwest Boulevard. You take 29th up the Midwest, go left, and it's right there.
Right there by Andy's Liquor.
Andy's Liquor Store.
Yeah, not that I go there.
Dude, you're not even old enough to drink. All right. Yeah, Chuck House it's just like Del Rancho. It's really good. And their sandwiches like crazy huge.
Yeah.
All right. Man, why would Doc talk about this food? Okay.
We always talk about food.
My mouth is watering now.
All right. Let's continue. All right. Testing for equality. All right. Now, for equality, we use the double equal sign, which those of you who finished your previous assignment would have known that already. The double equal sign is used to test for equality. It's not saying equals, it's like is equal to. It's asking the question, is it equal to? Okay. So when we're comparing two reference variables with the equals, you'd probably expect to return true. If the data in two reference variables are the same, unfortunately, it's not how things work. Okay. Let's look at this. So we have car 1, which is the new car. Okay. So car 1, we set the color to red. Are we okay with me so far? Car 2 is a brand new car. Okay? Car 2 is now red. Are they the same?
Well, the
So-
values of it would be the same, but they're in different locations.
They're in different. I mean, they're both cars and they're both red. But are they the actual same car?
No.
No, they're not. Let's prove that. Okay, so I got my mouse 1 here, and I'm going to create a brand new mouse 2. Okay. Now what I want to see is, let's get rid of this stuff. Don't need mouse 3 anymore. We're going to kill him. So if I compile and run this, they're both at different addresses. Do you agree?
Yep.
So if I say if my mouse 1 equals my mouse 2, can't spell tonight. Is it yummy or not?
It's not yummy.
It's not yummy?
Not in this example.
No, this example, no.
Aha! It's going to be yummy.
It's still yummy.
Which statement is going to break, the first one or the second one?
Second.
The second one. Because they're different memory locations. All right, now I'm going to modify it. And one of my students messaged me this weekend. It might be my previous student. I think previous student. He said, "Ha ha! I just watched your video. I see you referenced me in the video." I don't know who it was. And I always talk about my online class. I guess I talked about him in there, and so I don't know what I said, but I messaged him back and said, "What'd I say? Was it bad?" He never responded. So, oh well.
Was it the girl who cheated?
Oh, dude, I had some more this week. I graded them this morning. Yeah, it wasn't pretty. It was,
Or what,
no, I graded a program that had functionality we hadn't covered yet. But I didn't tell them they couldn't use it. So, sometimes I have students who are pretty advanced, so they do extra stuff. Then I graded 2 other students. Then I had another student who had the same exact advanced functionality. Like, wait a minute. Sure enough, identical. I mean, didn't even change the names of the variables. They were cut, paste. I was like, nice. So.
Maybe it was the guy who was like, send me a taped package.
Yeah, that was funny. Never heard back from him, by the way. Never heard back from him.
Wonder why.
All right, so what's gonna happen now? What do you think?
Chuck House is yummy.
Chuck House is yummy, you think? Chuck House is yummy. Because the actual values at mouse 1 and mouse 2 are the same. They're both holding 19821F. See that? So what happened was mouse 1 got this new mouse, 19821F. The mouse 2s get the same thing. So are they yummy? Sure enough, because they got the same value in it. All right, let's continue on. Does everybody understand why this returns false? Because they built 2 separate cars. They built a car and made it red. Built another car and made it red. Are they the same car? No. It's kind of like saying, Ken Dewey ordered a silver Chevy Volt. Now every silver Chevy Volt made is now Ken Dewey's. But also, if I didn't have to pay for them, that'd be sweet. So here we created 2 separate cars and both made them red. So obviously they're different. All right. All right. Continued. So the operator returns true if the 2 operators point to the same object, like we just did. So here, car 1 is a new car. Car 2 is equal to car 1, just like our mouse example. Then if car 1 is equal to car 2, they are, because car 2 is equal to car 1. Okay, everybody with me? It's just like mouse 2 and mouse 1. Chuck House is yummy. And if people want to listen to part of this, be like, what? No. All right. Is everybody okay with this? So these are the same. So we'll print out the same. Okay. But that's normally not good enough. Okay? Since usually the operator is not good enough, you'll usually want to compare the contents of the 2 objects than just whether the 2 variables point to the same object. to do that, we need to come up with some equals method. Kind of like we have the string equality, string dot equals, you know. Same thing. Okay, we can make our own. All right. Now we got a car2 class. It says write an equals method that will basically compare them. Okay. Now through the magic of Memorex, I wrote it on. Oh, it's not there. No, it's not there. Well, that sucks. Hold on. It's supposed to be there. I thought I unhid that slide. Okay. Don't look. This is top secret. It's right here. Can't look at this. I'm going to write it right here. Put it right. This mouse pad is terrible. All right. All right. Now, let's. This is. I just copied it in here so we can see it. Okay. So, actually, let me go back to the slide so we can see exactly the way it's being called. Our equals method goes there, and okay, where's the call to it? Oh, the call is at the bottom. There it is. Let's talk about this, and we'll go back to the equals method. Okay, so car2 is our new object called car2. We have make, year, and color. Everybody okay with that? Okay, we're going to talk about this missing part in a second. Now the driver for it, in other words, the program to run this thing, there's our main method. So Simon's car is car2, and Joe's car is car2 as well. So we have two brand new cars. One's called Simon, one's called Joe's car. Okay? So we have two different brand new cars. Okay? Now, then some other stuff happens, whatever. And we want to check if they're equal. So we say if Simon car dot equals Joe car. Just like if name dot equals Ken or whatever. You guys did first dot equals last or something like that on one of your programs you wrote. So Simon car dot equals Joe's car. So how does that dot equals work? Okay, let's look at it. Okay, here's the dot equals method. It starts there and goes right to there. Okay, so we receive an object. We're going to call it other car. Okay, so actually, so the call was, I'm going to write the call here. If Simon okay, that's what the way the call was written, okay? So basically it was called from Simon's car, and the argument we're passing is Joe's car. Everybody see this? So what's other car equal to? So this is the call for this. So I'm calling it from Simon's car. I'm calling the equals method of Simon, passing an object Joe car. So what's here? Simon or Joe?
Joe.
Joe.
Other car. Joe.
See, the dot equals method receives an argument. There's the dot equals method. There's the argument. So right there. So what happens is whatever the value is of Joe's car, like whatever the memory address is of Joe, is copied into other car. So we got a brand new object called car2 of type car2, and here called other car. So we made a temporary location for it. They were saying if this dot make, what is the make? Well, let's find out. The make's a string, so assuming we got a value for it. So it's saying if this dot make dot equals, see how we can chain all those things together? So we're saying if this dot make, so whatever the make of the car is, if that equals the other car, which is actually Joe's car. So if the other cars dot make, if they're equal, that's going to turn true or false. You agree with that? Then we have an and. Remember with ands, for an and to be true, what has to happen?
All values.
Both sides or all the values need to be true. So if this car's make, which now what is this? Is that Joe or Stacy? Joe or Simon? I'm sorry.
That is
Simon.
Right. So this is really Simon, and the other car is really Joe. So if Simon's car's make is equal to Joe's car make, and Simon's year is equal to Joe's year, and Simon's color is equal to Joe's color. So if all those are true, return true, else return false. Ever see how we did that? Okay. I just didn't feel like writing all that. Is everybody okay with me? Kind of? So what happens is that method goes up here. Then down here when we call it, if this returns true, then we print out cars have identical features. Are they the same car? No. It's basically like saying, hey, do you have a silver car? Do you have a green, whatever, is year 19, whatever, 2012? So basically we're comparing each one of the items. So, okay, so, what is it again, first name?
Denson.
Denson. I was talking about Damon in the last class, so I keep screwing
Let's
this
call
up.
me D.
Okay. So if D up here, so we're comparing cars. And I got a silver car. You got a silver car? Yes, good. Okay, good. So we both got silver cars.
It's close.
Then, all right, my car's a 2012. Is yours? Probably not.
2005.
Oh, let's go. But so, just because we got silver cars, are they the same car? No, because his year's not the same. But what if he did have a 2012 car? What if it was a Chevy? Would they still be the same car? No, but we could have the same features.
And the same color.
Exactly, and the same year and everything. It's just like, when I go to a restaurant and I say, okay, I want all you can eat ribs. Darn, I can't do that tomorrow. Next
Man, he
week.
still keep doing it.
So I can't do ribs tomorrow. So next week on Tuesday, I'm going to go to Rib Crib. And I'm going to say, Ken wants all you can eat ribs. Then I think John Paul wants to go with me. So if John Paul says, I want the same thing Ken just ordered, what's John Paul going to get? All you can eat ribs. But is he getting my ribs?
No.
No, he's getting his own ribs. They just happen to be the same type of order. What?
You can eat, that he is simply eating your ribs.
That's right. He could be eating mine because if he wasn't there, I could be eating those ribs.
Right.
But so he got his own order of ribs. Now, if they were the same ribs, we only have one bill. That'd be like ordering one plate of ribs and then splitting it. Okay. Everybody kind of with me? Maybe? Somewhat close? All right. All right. You know what? We got like 9 minutes left. I don't want to start this next section. So let's stop on 15 and we'll pick up on 16 next class period. All right. So we're going to pick up on 16 next time.